Today's lesson we're going to be talking about the Pythagorean theorem, which was invented by a Greek mathematician, Pythagoras, which most of math was also created by Greek mathematicians. So this is just one part of math created just by one of these many Greek mathematicians, ancient Greek mathematicians. Math is very old, but I'm getting off topic. Before we can actually talk about the Pythagorean theorem, you need to know what a right triangle is. So does anyone know offhand or maybe through previous knowledge as what a right triangle is and what makes a right triangle a right triangle? Well, if someone had told me that the right triangle is any triangle that has a 90-degree angle inside of it, then you would be 100% correct. So that 90-degree angle is what makes a right triangle a right triangle. Now, does anyone know what the sum of all the angles add up to in a triangle? If you said 180 degrees, you're also absolutely correct. So here I have drawn you a pretty genetic right triangle, and we specify the right angle, the 90-degree angle, with this little square. That tells us that that angle is 90, and since all the other angles have to add up to 180 together, 180 minus 90, the other two have to split the remaining 90 between them. They could be the same, they could be different, but their combination cannot exceed 90 degrees because 90 is already taken up by the right angle. So right angle again is any triangle that inside of it possesses a right angle. And we define right angles using these squares. It tells you that the right angle is, well, it's like that. That's what they look like. So that being said, if you have a right angle, you can use the Pythagorean theorem. But again, before I talk about that, I want to mention the sides of the triangle. Here I've labeled the sides A, B, and C. In a right triangle, one of the sides is always longer than the other two, sometimes by a decent margin. And we call this side hypotenuse, and it's labeled with a C here, and here I have the term. So C is hypotenuse. It's a term, I think it's a Greek term, sounds Greek, that simply defines the longest side of a right triangle. They all have three sides because, you know, it's triangles, they have three sides. Triangle, technically three angles, and each angle has a side. Side angle, side angle, side angle. So the longest side, which corresponds to the biggest angle, is called the hypotenuse. And in triangles, when we label the sides, usually it's done with A, B, and C. C is given to this longest side. So far, I've told you that a right triangle has to have a 90-degree angle, the right angle, and that we label the longest side, which corresponds to that largest angle, with a letter C, and it's also called the hypotenuse. Now the other two sides. The other two sides are equally important, but don't give them fancy names like the longest side gets. We don't have, any other names for the short sides. We just call them short sides or legs. They're also at times known as legs. So, you can say that that is leg A, and then the bottom one is leg B. So we'd call them legs. Leg A, leg B, and the hypotenuse or the long side. Now, usually, if C, C is always the longest, and usually B is assigned to the second longest side, and A is assigned to the shortest side, although A and B aren't that important, but to me it makes logical sense that if C is the longest side, B is the second longest side, and A is always the short side. So from this point on, that's what I want you to use. C is always the longest, B is that middle side, and A is the shortest side. If A and B are the same length, and that can happen, then it doesn't really matter which one you label A or B. But if one is longer than the other, one of the legs is longer than the other, I want you to assign A to the shorter one, B to the longer one, and then the longest side is always C. Now I've kind of talked quite a bit about this Pythagorean theorem, which I haven't really mentioned. And it's a formula. And the formula looks like this. If you take the square, or the second power, or power to the 2 of leg A, so A to the second power, and you add to that the square, or the second power of leg B, so if you sum the powers of 2 of the 2 legs, so A times A plus B times B, in a right triangle, they will always equal to the square, or the second power of the hypotenuse, the long side. So once again, the Pythagorean theorem, and this is it, this is the Pythagorean theorem, states that in a right triangle, if you take one leg, square it, so A times A, then add to it the square of the other leg, so A times A plus B times B, they always have to equal out, the sum of these have to equal out to the square of the hypotenuse, the long side, C times C. And that is the Pythagorean theorem. Essentially, it helps you find a missing side in a right triangle. As long as you know 2 of the sides, doesn't matter which 2, you can find the missing side, not a problem. And I can actually prove this to you as well. I have this little nifty video that's going to come up in a little bit, but before that, let me explain how that video works. Can someone tell me how can I find the area of a square? If you said take one side and multiply it by another side, and it doesn't really matter which side you pick since the square, they're all the same, so technically you only need one side. Take that one side and you multiply it against itself, you'll get the area of a square. So let's imagine that I had a square that was formed off the edge of this triangle. Another square that was formed, so let's say I had, again, 3 squares, one using this side as one of its sides, another square using this side as one of its sides, and a third square using the long side as one of its sides. So imagine there are 3 squares that exist like that, and here comes the video. Alright, hopefully you found that video fun. It's got some fun music and it explains why the Pythagorean theorem actually works. Because again, if you take the sum of these two squared, it always has to equal to that side squared. But let's use some numbers and see how this works when, some actual numbers are involved. So let's say that leg A equals to 6. And let's say that leg B equals to 8. And we're asked to find the long leg, leg C. So you're given the two short legs, or the two legs, and you're asked to find the longest side, the hypotenuse. Now, I have this nifty little formula that helps me do that, the Pythagorean theorem. And I have two sides. I have all the ingredients I need to find the longest side. So I'm going to plug in or substitute my values for A, my value for B, and then find C. And this is how I'm going to do it. First of all, I know A is 6, so if I take the square of 6, or 6 to the second power, and to that I add the square of B, which I now know is 8, it has to equal out to the square or the second power of my longest side, C. Okay, that's not so bad. Can someone tell me what's 6 squared? $36. Totally agree with you. Can someone tell me what is 8 squared? 8 times 8 is 64. Once again, totally agree with you. And all of that has to equal out to C squared. What's 36 plus 64? If you said 100, I would agree with you. Now I know what C squared equals to, but I don't know what C is. So, I want to get rid of this power of 2. Do I know what's an opposite of a power of 2? What can cancel out a power of 2? If someone said, take the radical of the second power, you're a genius, because that'll work. If I take the radical to the second power here, we know it's an opposite of power of 2. They cancel each other out. But I can't just do this to one side and leave the other side undone, because that unbalances it. So I also have to take the radical, the second power, from the other side as well. And remember, there's always that 2 there, even if we don't write it. Okay, this seems like it's going to work out after all. So let's see here. I can cancel out the radical to the second power and the exponent to the second power. Here, what's the outcome? I can write 100 as 10 squared, can't I? And when I put that under a radical, I can now cancel out the radical and the power of 2. So my C ends up equaling 10. And thus I found my missing side. That's all it was. Any questions on, well, this explanation? Let's do a few problems for practice. Alright, so once again I have a right triangle, and we know it's a right triangle because it has this 90-degree right angle in there. And we are given one leg, we're given another leg, and the longest side, C, the hypotenuse, is missing. How can I find C if I know the other two sides? What can I use? If you set the Pythagorean theorem, I would agree with you. Of course we can. And this one you do have to memorize. So yay for memorization, right? It's okay. You'll get to use it over and over in math. So it's not like something you have to memorize now and you'll never use again, which is true for almost all math. So here it is, the Pythagorean theorem. If you know two of the sides, you can find the other. In this case, we're looking for a long side. What's A? What's B? As I told you, I like to label my shortest side as A. So I'm going to have the 5 be A. And my second shortest or second longest side, depending on how you want to say it, gets to be B. That's B. And of course the longest side, the hypotenuse, is C, but it's missing. It's what I'm looking for. So what do I do next? I'm going to substitute my known values, of course. So instead of A, I'm going to write 5 squared. To that I'm going to add the other side. So B is 12, and it had a power of 2 there, so it's 12 squared. And all of that equals out to C squared. Can someone tell me what's 5 squared? 5 times 5? 25, of course. What about 12 to the second power? What's 12 squared? 12 times 12. 144. And all of that equals to, once again, C squared. Can someone do some quick math for me and tell me what's 25 plus 144? 169, you say? I'm in agreement with you. Now I know what C squared is, but I don't know what C is. How can I isolate the C? How can I get rid of this power of 2? If you said take the C to the second power under a radical to the second power, I would agree with you. There we go. I don't have to write the 2 there because, again, a standard radical is automatically of the second power. And of course I got to do it to the other side as well. Can't leave one side done and the other one undone. Now on the right side, matters are very simple. Canceling the radical to the second power and the exponent to the second power, they're gone. On the left side, is 169 a perfect square? It is. It most certainly is. And what is the exponential formula, the positive exponential formula of 169? If you said 13 squared, or 13 times 13, I totally agree with you. So 13 to the second power is indeed, I'm going to pause this real quick. It's 13 to the second power, and the reason I had to pause is because I shouldn't have wrote that radical. It's already been canceled out. All I have left is a C here. So now I'm going to cancel out my radical to the second power on this side with its exponent to the second power, and I'm left with just 13, which equals to a C. And voila, I found my missing side. All done? Questions? Let's do one more example just to solidify our understanding here. All right. Now, with that problem, it's similar to the other one, except I have the shortest side missing. So my shortest side is unknown. I know my other two sides, so once again, what can I use to find my missing side? If you said the Pythagorean theorem, correct. A squared plus b squared, and all of that equals out to c squared. Great job, class. Now I don't know my a, but I know my b and c. Which side should be c? The longest side. So that means out of these two, the 15. And it's also in front of the right angle, the 90-degree angle, so that makes sense. That's going to be my C. And of course that leaves 12 to be my B. And now I'm going to substitute my values in. So I don't know what A squared is. I still don't. But I now know what B squared is. Or B is, it's 12. So it's going to be 12 squared instead of B squared. And I know what C is for a change. C is 15. So all of that equals out to 15 squared. The sum of the shortest side plus, the second power of the shortest side plus the second power of the middle side equals out to the second power of the longest side. What's 12 to the second power? And what's 15 to the second power? Twelve times 12 is 144. And 15 times 15 is 225. All right. Now I need to isolate the variable. I want a squared all alone. I want to get rid of this plus 144. How can I do that? I can of course subtract 144 from both sides. Of course I can do that. So they're gone right here. Choose a different color. So these are gone. And what's 225 minus 144? If you said 81, I agree with you. So a squared, equals to 81. And I'm not done yet because I have, and that's an a, sorry. Let me get rid of that extra long tail. So I want a, not a squared. So what can I do? How can I make that a squared into an a? Take the radical of the second power, and if I do it to one side, I got to do it to the other side as well. So on the left side, it's easy. Gone. So I'm just left with an a here. And what is the square root of 81? I don't want to do all the work. 81 is 9 squared, so the power of 2 and the radical will go away. So I'm just left with 9. Oh, Lord, that's going to be awkward. My a and the 9 in one problem next to each other. The universe is going to collapse on itself. Anyways, a equals to 9, so that's my missing side. It makes sense too. It's got to be shorter than the other two sides. So, and it is. It's shorter than B or C. Perfect. It all works out. So any questions on how to find a missing side in a Pythagorean theorem? You take your two that are available, you plug in those in, and then you just find the one that's missing. A, B, or C, doesn't really matter which one's missing. You have to know the other two though. If you only know one, you're in trouble. That's not going to work. Alright, now let's do something a little bit different. So a neat thing about the Pythagorean theorem is that because it's based off a right triangle, it only works in a right triangle. So if you're given three sides and you don't know if that triangle is right or not, you can use the Pythagorean theorem to figure it out. Because if you plug them in and the theorem works, it has to be a right triangle. But if you plug them in and the theorem breaks, doesn't work, then you know you don't have a right triangle. So this is using the Pythagorean theorem in reverse. So for example, I gave you these three numbers. They're the sides of the triangle. We're trying to figure out if it's a right triangle or not. 1, 2, and 3. So I'm going to plug this in into the Pythagorean theorem, which I'm going to rewrite. And again, you do have to have it memorized. I'm not going to give it to you on a quiz. A squared plus b squared, if I had to memorize it, equal to c squared. Now I'm going to decide which sides are A, B, and C. And as I told you, I like to make it easy. Shortest is A, second shortest is B, longest is C. So I'm going to say that that one's A, that one's C, and that one's B. So now I'm going to go ahead and plug them in and see if they work. If I have the same thing on both sides of the equal sign, then it's a right triangle. If not, then it's some other kind of triangle, or maybe it's not even a triangle at all, but it's just three random sides. Let's make that work. Let's make that work. That means I'm going to have, instead of a squared, I'm going to have 1 squared. Instead of b squared, I'm going to have 2 squared. And instead of c squared, I'm going to have 3 squared. Okay, what's 1 to the second power, or 1 squared? 1 times 1, which is just 1. What about 2 to the second power? What's 2 times 2? That's 4. And what's 3 to the second power? 3 times 3, 9. You can probably already tell this isn't going to work, because 1 plus 4 is 5, and that's not 9. So you can safely say that this triangle, if this is a triangle, is not a right triangle for sure. That you can tell for certainty. These sides would not make up a right triangle. No way. So any questions on how I did that? It's a simple little neat trick that you can do once you know the Pythagorean theorem. Let's try one more. Slightly bigger numbers. Woohoo! Works out the same way. Again, I'm going to write my Pythagorean theorem. A squared plus b squared. There we go. Equals to c squared. Again, I'm going to choose my sides based on length. Shortest is going to be A. And that's an A, not a 9. Yes, I'm annoyed too. The middle side becomes B. And the longest side is, of course, C. The hypotenuse. And I'm probably going to make you write that on the quiz, the hypotenuse. So, yes, cruel and necessary. Now I'm going to plug my numbers in. A is 5. So instead of a squared, I'm going to have 5 squared. So that's going to be 8 squared instead of b squared. And of course c is 12, so that's going to be 12 squared instead of c squared. Now let's do our number calculations. What's 5 times 5, or 5 squared? 25. What's 8 times 8, or 8 squared? Or 8 to the second power? 64. And what's 12 squared, or 12 times 12, or 12 to the second power? 144. And 25 plus 64 is not going to give me 144. It will give me 89, which is not even 100. So 89 does not equal to 144. It just doesn't. So once again, whatever this triangle may be, it's not a right triangle, even if it's a triangle at all. So the only thing you know for sure, that is not a right triangle. Sorry. Let's do one more, because since we've had two that aren't, the last one's got to be it, right? It would make sense for me to give you all three that don't work, right? Right? All right. Last one. So, once again, write out the Pythagorean theorem. Thankfully, if you write it enough times, it kind of just sticks in your head, like an unwanted memory that you can never get rid of. That's what I want. Alright, then let's label our sides. Shortest becomes A, middle child becomes B, and the longest becomes C. Let's plug it in. So instead of A squared, I'm going to have 7 squared now. Instead of B squared, I'm going to have 24 squared. Oh, that's going to be a big number. I want to use a calculator for that one. And C squared is actually going to be 25 to the second power. I know what that is. I don't need to use a calculator on that one. 24 squared I do, but 25 I actually know off the top of my head. I'm that cool. Alright, so you should all know what 7 squared is. So can someone enlighten me? 49, of course. 7 times 7. 24 times 24, calculator time while you get the answer. $576. You could have used long multiplication. I use the calculator because I don't have to take my own quizzes. Now 25 times 25, I know that because it's a perfect square. It's one of the bigger ones, but it's 625. I don't know them all, but some remain in your memory. Again, memories you can't get rid of. Let's do some math. 49 plus 576, what is that? It's 625, and it equals to 625. Yes, the Pythagorean theorem works for this set of sides, which means this is indeed a right triangle. Yay. And that's it. 2 things we learned today: what a Pythagorean theorem is and how it works, and how to use it in reverse to find if the triangle is right or not, if it has a right angle or not. Questions before I sign off? All right, thank you very much.